Electromagnetic switches can be 100 times faster than traditional mechanical switches. Imagine having a light switch that can turn on and off in milliseconds. This is the realm of electromagnetic switches, which use the power of magnetism to control the flow of electricity. But how do they work, and what makes them so fast? To understand this, let's first look at the traditional mechanical switch. A mechanical switch relies on physical contact to make or break the electrical circuit. When you flip the switch, it physically moves to connect or disconnect the circuit. However, this physical movement can be slow and prone to wear and tear. In contrast, electromagnetic switches use a magnet to create a controlled flow of electricity. This magnet is typically an electromagnet, which is a coil of wire that carries an electric current. When the switch is turned on, the electromagnet is energized, creating a strong magnetic field. This magnetic field interacts with a nearby ferromagnetic material, such as iron or nickel. As the magnetic field changes, it induces an electromotive force in the ferromagnetic material. This electromotive force, or EMF, creates an electrical current that flows through the circuit. But that's not the strangest part. The magnetic field can also be reversed. When the magnetic field is reversed, the EMF is also reversed, allowing the switch to toggle between two states. Wait until you hear what comes next. Electromagnetic switches can also be used to create complex logic circuits. By carefully arranging the electromagnets and ferromagnetic materials, it's possible to create switches that can perform complex logical operations. For example, you can create a switch that acts as AND and gate, only allowing current to flow when both inputs are present. Or you can create a switch that acts as an OR gate, allowing current to flow when either input is present. This means that electromagnetic switches can be used to create complex digital circuits, making them incredibly useful in modern electronics. And then something unexpected happened. Researchers discovered that electromagnetic switches could also be used to create quantum computers. That's right, the same technology that allows us to create fast and reliable electronic switches also has the potential to revolutionize computing as we know it. So how do electromagnetic switches work in practice? In a typical electromagnetic switch, the electromagnet is connected to a small piece of ferromagnetic material. When the electromagnet is energized, the magnetic field interacts with the ferromagnetic material, creating an electromotive force. This electromotive force is then used to control the flow of electricity through the circuit. But what about the speed of these switches? Well, it turns out that electromagnetic switches can be incredibly fast, much faster than traditional mechanical switches. In fact, some electromagnetic switches can turn on and off in as little as 10 nanoseconds. That's incredibly fast, and it's one of the reasons why electromagnetic switches are so useful in modern electronics. However, electromagnetic switches are not without their drawbacks. For one thing, they can be sensitive to external magnetic fields, which can interfere with their operation. Additionally, the electromagnets and ferromagnetic materials used in these switches can be expensive and difficult to manufacture. So what does the future hold for electromagnetic switches? One possibility is that they will be used to create even faster and more reliable electronic switches. Alternatively, they may be used to create new types of digital circuits, such as quantum computers. Whatever the future holds, one thing is clear: electromagnetic switches are an important part of modern electronics. So if you found this fascinating, subscribe for more incredible stories like this. And let me know in the comments what fascinates you most about electromagnetic switches. Thanks for watching, and we'll see you in the next video. If you want to learn more about the science behind electromagnetic switches, be sure to check out our next video.